Your poor back and your poor shoulder. I've put you through the mill, haven't I? And we start off with a familiar scene down Red Bull Way, the car being cradled off a flatbed truck. Indeed, the flatbed truck has done more laps at this test than the Red Bull RB10. There's a statistic that you might have heard already, or you might not. So all the guys sort of keen to keep it covered up as they unload it. So the problem, if you haven't already heard, is that Adrian Newey just seems to be a packaging issue. Every time it went out on track, everything would get very hot. We're not absolutely sure whether it's a problem with the battery cells all overheating or the control systems for the battery, whether Adrian has packaged them all too tightly and whether it's all just got very hot. But it seemed like whenever it goes out, it overheated, and then that was it. They ran today on the last day with a kind of downgraded, derated system where they weren't putting too much charge through the battery, a very kind of test way of running without putting maximum power through any of the ERS-K or the ERS-H. So a bit of a mess. Really wouldn't have learned all that much, but it was important for them at least to get some laps on the board. Daniel Ricciardo in the end did 7 laps and was slowest of all. Just checking the screens here. Not that the times make any difference, but 7 laps. I like to think that maybe they were sort of PR laps, but I think the team wanted to learn something at least and did get a little bit of running. But you can see this is what happened whenever the car came back. This little fella, I like the way he's squatting down to see, and Kenny, the chief mechanic, knowing only too well that these things can happen. But you'd be a fool to write Red Bull off, at least at the moment. But we can just have a look at how tight everything is at the back. And just look at this, Pete. I mean, beautiful the way it comes out and round in the Coke bottle shape towards the back end of the car. The exhaust pipe also being used as a part of the cooling in this sort of tulip effect here. But have a look, Pete, just at these 2 bits here. We've got the one on the left here. This is a little outlet, and the one on the right. Now, these were very hurriedly cut out of the bodywork overnight between days 3 and days 4 to try and give the cooling, a bit more cooling to the battery and the control unit elements around there. So that gives us a clue as to where Adrian Newey has mounted them, very low down in and around the bottom of the engine. That's where they would be before the gearbox is here, of course, and then turbocharger attached to the exhaust pipe. Not allowed to have any bodywork around the exhaust pipe, but just have a look at the diameter, the bore of that pipe there, and the radius, and just keep that in mind, because you'll see the Ferrari, which is a bit bigger. Nice little cascade wings on the rear wheel hubs there. So all the rest of it is fantastic. No pillar supports, interestingly, on the Red Bull. They are allowed, and no evidence of a monkey seat either just yet. But the rear wing is actually held on by this beam here and just these little points at the bottom. You can just see the rear wing being held on there. So that's impressive structurally, the way they managed to actually get the downforce from the rear wing to stay on. Just a quick mention of DRS. We do still have DRS. A couple of people have asked me whether we do still have DRS. We do, but because the rear wing angle is shallower, no more barn door angle rear wings, it's a shallower rear wing, and of course that would have meant that the DRS, because there's less drag anyway because it's a shallower angle, there wouldn't have been quite so much drag to dump with the drag reduction device. So what they've done is beefed up the DRS. They've made it so that it can open, the hole can open by a greater degree. So when the DRS flap does open, you'll see it opening wider. It's about 65 millimeters. Here you can see, Pete, if you want to just come back down, just how tight Adrian Newey has packaged the rear of the car. Look at that. No surprise then to some people that it is all getting a bit too hot and close and overheating on there. And just with the single cooling exit that you're allowed at the back, that is tight as anything, isn't it? He's put a hole in the front, the S duct. There's a little duct at the front there. Don't know if you can see, just downstream of the number 1 on Vettel's car there. So that is acting as it did, takes air just from underneath and exits it over the top of the chassis just as it did. And these 2 cooling vents, the louvers on either side of the cockpit, they are new and recessed for this year, so pretty good. We'll have a look at the nose in a minute. There you can see the nose, and quite a nice solution actually, to considering all the really ugly noses we've had. Newey's just done a very flat nose section, rounded at the front, and then he's put this sort of what looks like one of those plastic bumpers that you get on bumper cars. It's actually made of carbon fibre. I'll have a closer look at it in a sec. On the front, just to satisfy the rules. So that's a sort of legality bulge, shall we call it. But the rest of it looks very nice and aerodynamically efficient. This car would actually be illegal if it was entered in a race at the moment, because it doesn't have the front wing camera mounts, which should be somewhere there. And they're not on there. I think Red Bull considered that was the least of their problems and didn't bother putting them on. But they should be there, and they should appear by the time of the Australian Grand Prix. Just look how much space there is at the back for all the airflow. Beautiful job he's done. If only it worked, which it doesn't. Also, these little bits coming down, nice little detail, beautiful little detail either side of the cockpit there. Can have another shot of the diffuser. The teams are going to hate us for showing you pictures like this, just to see. It's a pretty standard diffuser, similar to the one they had last year. No rear beam wing. The rear beam wing would have been about here, above the rear crash structure of last year, but that's not there anymore. So yeah, that's how the rear wing rather, is held on. You can see there. Let's start to rattle through these. It's a shot of the louvers that I mentioned there. They sort of stuck up last year, but now they're nicely sort of pushed down and recessed in flow with the bodywork. This was the car being wheeled back when it wasn't on fire, and just another shot of the rear wing, which I thought was quite nice. The angle of these tower barge boards I thought was interesting. Look at how they're sort of, well, they're angled towards the direction of the front wheels, because the front wing is narrower, the air around the front wing is coming in a different direction. Now it's coming sort of up, some of it's coming inboard, inside here, and then you can imagine it's being checked at that angle around the side and the back of the side pods towards the end. So some nice angled detail on the Red Bull. There's a close-up of the Legality Dodgems car bumper nose, and you can see a bit closer that it's actually got a vent in it, so that it's not just building up air pressure at the front. It actually allows some air through it. That's what it looks like in the side view. Nice new thinner front wing end plate on the Red Bull as well. Right, let's move on to the Mercedes. Yeah, nice packaging. They've got this nose that we'll talk about on the front wings at the second. They've got interesting camera mounts which come out in a little winglets on here. They're aero positive, those camera mounts, which is particularly impressive for Mercedes. They actually help the aero. They're positive for the aerodynamics, and also pretty tight at the back. Not quite as tight as the Red Bull, but the Mercedes does have the pillars and the DRS there, of course, that the Red Bull does not. Nice detail on the front wing end plate for the Mercedes, but they did have this problem when the front wing fell off. Oh, sorry, that's the front upright, which is nicely sort of aerodynamically shaped. Nice bit of detail there. So they had a problem with the front nose when the nose fell off with Lewis Hamilton. It fell off around this area. You can actually see a very nice detailed front wing, by the way. Lots more downforce there. So you can see this is the picture of the front wing in the back of the van that came and picked up Lewis Hamilton. So you can see where it's come off. That's the mounting point between the pillars and the front wing. So that's okay. It's just above that. You can see where it's just sheared off on that side and sheared off on the other side as well. So that meant, after a lot of work at Brackley at the Mercedes factory, they came and they'd fixed it. So that's what it looked like before, nice smooth surface. And then after, when they came with a new one, can you see, Pete, this sort of line there of beefing up, of reinforcement. So that's what they'd done just to beef up that area. That did add weight in that area, weight that they'll have to get off. Because as we said in the notebook yesterday, we think the Mercedes is already a little overweight. Paddy Lowe, the Chief Technical Officer, kind of admitted to that, the head of the co-team principal. This is the rear of the car. Nice limited cooling, not huge outlets. Of course, the tighter your cooling, the better your aerodynamics, and not the most massive exhaust pipe compared to the Ferrari, but some nice detail in there. You can get a bit closer on that. It's pretty beautiful. You can see how the exhaust pipe is angled up slightly. That's it has to do that in the rules, and it helps with the aerodynamics. Now, that's the monkey seat which came onto the car. Nice curved monkey seat. You are allowed a little winglet, which we call the monkey seat, in the middle of the rear wing. So that's what that one is doing there. If you have a look at the airbox here, it's split into several bits, something Mercedes were experimenting with. Some other teams have done this, different parts of air being channeled either to turbo cooling or engine cooling or intercooler, or actually the intercooler's going to come in the side pots. What am I talking about? But gearbox oil casing perhaps as well, gearbox radiator being fed through the airbox as well. There'll be a little input inlet in there too. Now we move on to the Ferrari with its flat nose. Something to point out here, this is just a sort of airspeed speed measuring device. People have asked what that is. Really nice thin side pods. Now that's because we believe the Ferrari has the edge on engine cooling. We believe it can run the coolest of all. It's done the best job. Ferrari, paddock rumour is amongst us techies that Ferrari have done the best job on engine cooling, so all credit to them. That means they can run tiny radiators, pretty much the same size radiators as last year, which is amazing considering the increased cooling demands that it has this year, with a massive turbo pumping out 900 degrees C. So well done Ferrari, and that means that they only have a small engine air intake. Well, that's pretty much common to a lot of the Ferrari cars. Better view there of the back of the car. They can have not a very tidy rear of the car. Now there's a story going around about the turbo casing in the Ferrari. There's a rule that says that you have to ensure that if your turbo fails, the turbine will be contained within the engine cover and won't come and break out of the engine cover and fly off into the crowd and injure somebody. So there's a story going around that all the other teams have managed to do this by reinforcing the engine cover. So you've got quite a sort of like a ballistic shield in the engine cover with sort of 4 kilos of weight up there, just to check that nothing actually flies off. Now, of course, that's weight far up that you don't want. But the rumour is that Ferrari have just built a very, very strong turbo casing, which, if the turbine did fail, the casing would actually keep it in there, and that's meant that even though the turbo casing is heavier, that's meant that it's a net weight gain, because they don't have to then put the huge 4 kilo ballistic shield on the engine cover, which is weight high up. So that's the rumour. We'll find out if that's true later on in testing, I'm sure. Another nice view of the rear of the Ferrari with the shaped pillars going up to the rear wing. Yeah, you can set a better view towards the back, Kimi Räikkönen there, of all the space that Ferrari have got to play with. Look, they don't even need the full legality space of the floor there to fill up. The nose is interesting, a sort of squashed nose. I'll just have a look at these new cool, funky strakes, little vents. Something they had last year, Ferrari, and they've done more of the little air intakes on the side of the rear wing for aero efficiency. Something about the nose that actually creates a low pressure. If you were listening to the notebook the other day with Mark Smith from Caterham, so the flat nose, what it does is actually creates a low pressure area underneath it. So of course, low pressure there, high pressure there, instant downforce. So that's good downforce at the front of the car. There you can see it actually, Pete, if you can see this, with the aero paint gives it away. It's sucking air, can you see that, down underneath, and the front wing end plates doing their job as well. Now Lotus is next. This is a picture that Mark Hughes, my colleague on the Sky Sports F1 website, did about how he thinks the Ferrari, by this picture, and we tried to scale them together, has a longer wheelbase, and that would certainly look like it on this picture, and therefore can create more downforce. We haven't seen the Lotus, of course, but they've got the 2-pronged nose. One end is longer than the other. That's because it has two. This is the end of the nose that counts as the nose, and so that one just counts as another bit of bodywork. That's the one that makes it legal, and that's the one that makes it into a nice sort of aerodynamic shape that the aerodynamicists think that the air is just going to come in underneath and then go round underneath the car and to the back. So that's the thinking on that one. That's what we think the Lotus is going to look like. Very nice it is too. We will see. Now to the McLaren. Yes, now this is interesting. I'll try and rattle through this as quickly as I can because we don't have limitless time. There is these little chimneys coming out the side. That helps the cooling. The nose, which I guess is the most pretty of the pencil or the banana noses, they've also got a split in their air intake and a nice monkey seat on the back of it. But this is what you want to see, and these are the fat wishbones. Now, are these legal? Well, we'll see. I don't know if you can see in some of these pictures, but they've got a kink in it. It's not actually straight. It comes out and does a little bit of a dog leg rather than a wishbone just being straight like that. It comes out and it's got a bit of a dog leg between there, so that these large bits can be square on to the air coming out of here. So the legality question is whether, with the primary purpose of suspension being to suspend the car, whether its other purpose, of course, is for aerodynamic gain, given that you wouldn't normally have a suspension part, a compressive part, that has a kink in it. You wouldn't normally be done. So that gives the primary purpose of is it suspension or an aero part into question. Of course, its primary purpose is to keep the car suspended, but still, I'm sure there'll be an argument about that. You've got air coming in here, and it's being checked up by there. It's just blocking off this area. It's to replace the lower beam wing that we spoke about a little earlier. Effectively, it just makes the diffuser work harder, and is being looked at in CFD and wind tunnels by every other team. If they can get it to work and it's proved legal, then they will put it on their cars. So some teams are preparing a protest about it and preparing their own version in the wind tunnels at the same time. Such is the way Formula One goes. So nice idea. There was a thought by Sam Collins, a colleague of mine from Race Car Engineering magazine, that actually it might be there as a cooling aid as well, or its secondary help might be a cooling aid, in that it creates low pressure here and actually sucks hot air out of the side pod exits here and creates effectively a thrust of air into the side pods and would help cooling. Nice idea. I wonder if that is absolutely true. There you go. There's a lovely close-up of it. McLaren probably aren't going to like us showing you that, but there you go. Such is our technology. We can do that and let you have a good look at those fat wishbones. That's what the McLaren looks like from the top. Not quite as closely tied in as the Ferrari or indeed the Red Bull, but still looks pretty tidy. They've gone back to the push rod front suspension. You can see here, after the disaster of the pull rod last year, the only two teams who have pull rod suspension this year are Ferrari and Caterham. Interestingly, Caterham decided to go down that route. Some nice detail around the car. You can see the split airbox above Kevin Magnussen's head, and the nose. Yeah, a cheeky little fellow, isn't he? With a nice sort of smile, and I don't know what that line is around the outside. In case it gets knocked off, they can stick a new little bit of smiling little fella on there, I suppose. But nice front wing, much more intricate front wing than last year on the McLaren here. So nice job by their aerodynamicists. Right, let's move on to Force India. They have really gone for an aggressive cooling at the back. Look at that, very nicely shaped at the back there. Unfortunately, that's where it all starts to go downhill for Force India, because we've got this fella. Oh dear. I mean, I know the FIA writing to the teams and seeing, they're all structural, but these are structural, asking them if they're properly structural. These are structural, so, they passed the crash tests. Of course, it's for aerodynamics. This is to keep it legal, because the nose rules say that you have to be this point above the ground, 180, whatever, 180 millimeters, or I think it is above the ground there. But then that needs to be around here, and it needs to be around 525 millimeters. So that's how you keep it high for the aerodynamicists, because they want a high nose, but low for the rule makers. And doesn't it look strange? Oh, there's another one. Where did you come from, sir? Yes, okay. A couple of you were wondering how it works with the front jack. Well, very easily.